From a distance of millions of miles, Jupiter appears serene. It is a world of swirling creams and oranges, centered by a great red spot that looks like a calm, permanent feature of the sky. That serenity dissolves the moment you cross into its territory. Radiation alarms scream as high-energy particles shred your sensors. Your navigation instruments fail entirely, feeding you garbage data as the spacecraft's hull buckles under violent, unseen forces. Surmounting this hostility requires an understanding of Jupiter's incomprehensible scale. You could fit over 1,300 Earths inside its volume. It outweighs every other planet, moon, and asteroid combined, twice over. During its formation, Jupiter gathered so much material it nearly became a star. Had it captured just 80 times more mass, the core would have ignited nuclear fusion. As a second sun, its massive gravity would have destabilized the inner solar system, likely flinging the debris that formed Earth into the void or into the sun before our planet could ever coalesce. Instead, the solar system was left with a gas giant possessing no solid surface and an appetite for destruction. It represents a hard limit for human engineering, a place where our most advanced probes operate on borrowed time. The Great Red Spot has raged for at least 4 centuries, a storm large enough to swallow Earth whole. Wind speeds at its outer edges exceed 400 kilometers per hour. Even higher speeds exist deeper in the atmosphere, where jet streams tear across the planet at over 600 kilometers per hour. These are massive walls of gas moving faster than the speed of sound on Earth. Because Jupiter has no solid ground, there is no surface to crash into. If you fall in, the atmosphere simply grows thicker and hotter as the pressure rises with every kilometer you sink. Eventually, the weight of the atmosphere becomes so intense that the standard laws of chemistry begin to fail. Deep inside the core, the pressure forces hydrogen gas into an exotic state, liquid metallic hydrogen. This churning metallic ocean acts like a massive dynamo, generating a magnetic field 20,000 times stronger than Earth's. It is the largest structure in the solar system, extending millions of kilometers into space. This field actively weaponizes the space around the planet, trapping charged solar particles and accelerating them to near light speed. This creates radiation belts that would kill an unprotected human in minutes. NASA's Juno spacecraft requires a 200-kilogram solid titanium vault just to shield its computer from these particles. Even with that armor, Juno can only survive close passes for a few hours before the radiation threatens to fry its systems. The Galileo probe provided the ultimate proof of this hostility in 2003. It absorbed the equivalent of 25 million dental X-rays before it was finally crushed and vaporized in the depths of the atmosphere. Jupiter's internal physics create a local environment that actively destroys anything attempting to orbit it. Jupiter's gravity has dictated the history of the solar system. The Grand Tack hypothesis suggests that Jupiter's early migration inward cleared out material that would have become other planets and limited the growth of Mars, leaving only the debris of the asteroid belt behind. This gravitational bullying continues today. In 1994, Jupiter's gravity captured comet Shoemaker-Levy 9 and tore its nucleus into 21 distinct fragments. Those fragments slammed into the atmosphere at 60 kilometers per second, releasing energy equivalent to millions of nuclear bombs and leaving dark impact scars larger than Earth. Jupiter also tortures its own moons. The tidal forces are so extreme they continuously knead the moon Io like dough. This friction makes Io the most volcanically active body in the solar system, with a surface that reshapes itself every few years. Jupiter's gravity remains the dominant architect of our neighborhood, dictating the orbital paths and survival of every object in the solar system. Astrobiologists look toward the moons Ganymede and Europa as potential habitats for life, specifically looking for liquid water beneath their frozen surfaces. However, Europa exists within the heart of Jupiter's radiation belts. Any mission to its surface faces a lethal environment, requiring probes to drill through kilometers of ice just to find shielded water. Even Ganymede, the only moon with its own magnetic shield, is overwhelmed by the sheer intensity of Jupiter's particle bombardment. These icy worlds exist in a radioactive hellscape, permanently trapped by the invisible influence of a 4.5 billion-year-old storm. Jupiter is a laboratory for physics we cannot replicate on Earth. Studying its radiation and metallic core allows us to understand the mechanisms that shape gas giants throughout the universe, but it remains an unconquerable territory. Humanity will never build a base in its clouds or walk on its surface. Our robots survive only by running away, utilizing orbits that minimize their time in the radiation zones. Jupiter has raged since before life appeared on Earth, and it will continue long after we are gone. When you see it as a steady point of light in the night sky, you are looking at a radiation source that can kill in minutes, and a gravitational well that has shaped the fate of worlds. It is the king of planets, because nothing else in the solar system survived long enough to challenge it.